Welcome. In the second video we will work on problems 3 and 4. So for part A of 3, how many integers from 1 through 1000 are multiples of 3 or multiples of a? So we use the principle of inclusion-exclusion pi for solving this problem with the following two sets. A being the multiples of 3. Always we work only with integers 1 through 1000 only in this program. B multiples of a, and that means the intersection A intersection B are multiples of 3 and 8, which is 24. A union B are multiples of 3 or 8. That's what we would like to count. So for the number of elements in A, multiples of 3 every third, so that's floor of 1000 divided by 3, that's 333. Number of elements in B, every 8, so 1000 divided by 8 and the floor of it, which is 125. Number of elements in A intersection B, which is 1000 divided by 24, every 24th. And floor of that is 41. So by the inclusion-exclusion, number of elements in A union B is number of elements in A plus number of elements in B minus number of elements in the intersection. Plugging the numbers, 333 plus 125 minus 41, that's 417. So that's 417 is the answer for A. Let us look up for B. How many integers 1 through 1000 are neither multiples of 3 nor multiples of a? So number which are neither multiples of 3 nor 8, using the difference rule, is 1000 minus 417, which is 583. And that's the answer for part B. Alright. So now for the problem number 4. 8-bit string, which is 1 byte, so string of 0 ones of length 8, is sent over a network. The valid set of strings recognized by the receiver must either start with 0 1 or end with 1 0. How many such strings are there? So A will be the set of strings of length 8 starting with 0 1. So that leaves 2 positions open out of the 8, so we have 2 to the 6 of those. B will be the strings of length 8 ending with 1 0, so again 2 to the 6 of them. And now we need to look on the intersection, because there are strings which start both with 0 1 and end with 1 0. So A intersection B is the number of strings of length 8 starting with 0 1 and ending 1 0. So that leaves only the 4 middle positions open, so 2 to the 4 such strings in the intersection. And finally A union B is the strings of length 8 starting with 0 1 or ending with 1 0. That's what we want to count, so we get A n number of elements in the union. By the principle of inclusion and exclusion is number of elements in A plus number of elements in B minus number of elements in this intersection, which is 2 to the 6 plus 2 to the 6 minus 2 to the 4. Evaluated is 112. So 112 is the answer to the question. Thank you.